Ever find yourself scrolling through photos and your phone like magically groups them by faces? Or maybe you've seen those self-driving car videos and wondered how on earth a machine can navigate traffic.
Right.
Well, the answer might just lie with the work of Karen Simonyan.
That's right. One of the key figures behind how computers see the world today. His work isn't just about lines of code. It's about fundamentally changing how machines understand images and videos.
Okay, I'm intrigued. So we're not just talking about some tech whiz coding away in isolation, right?
Yeah.
What's the story behind Simonyan's journey to AI stardom?
Even early on, Simonyan had a natural inclination towards math and computing.
Yeah.
Which is a pretty solid foundation for anyone stepping into the world of AI.
Right, because it's not just about programming.
Yeah.
It's about the logic and the mathematical underpinnings that drive these systems. But how did that early interest translate into groundbreaking AI research?
Well, picture this. Oxford University, the Visual Geometry Group, a hub buzzing with some of the brightest minds in computer vision.
Wow.
That's where Simonyan landed, learning from giants in the field like Andrew Zisserman.
Wow. Talk about a breeding ground for innovation.
Yeah.
And I bet this wasn't a solo mission, right?
Yeah.
Was this more of a collaborative effort?
Absolutely. The VGG fostered a culture of teamwork, a constant exchange of ideas.
Yeah.
This collaborative spirit was key to their success. Think of it like a Renaissance workshop.
Okay.
Where artists and thinkers came together, sparking off each other and creating breakthroughs.
So what was their masterpiece? What did they create that really shook things up in the world of AI?
Enter VGGNet, a deep learning model that revolutionized image recognition.
Okay.
Before VGGNet, image recognition algorithms struggled with accuracy and complexity.
Yeah.
But Simonyan and his team managed to crack the code, so to speak.
That sounds like a pretty big deal.
Yes.
But for those of us who aren't deep learning experts, can you break down what makes VGGNet so special?
Imagine trying to teach a computer to see, to understand the visual world as we do. That's essentially what VGGNet achieved. It's a network of artificial neurons, layered in a way that mimics the human visual system.
Okay, I'm listening.
Yeah.
But how do these neurons actually learn to see?
Each layer of the network focuses on different aspects of the image.
Okay.
The first layer might detect simple edges and textures, while deeper layers identify more complex shapes and patterns. This hierarchical structure allows the network to build up an understanding of the image layer by layer.
So it's like the computer is gradually learning to recognize the visual world.
Yeah.
From basic shapes to complex objects, kind of like how we learn as children.
That's a great analogy.
Yeah.
And the more layers you have, the deeper the network, the more sophisticated its understanding becomes.
Yeah.
That's the deep learning.
Fascinating. But how did they actually prove that VGGNet was the real deal?
Yeah.
Did it face any real-world challenges?
Oh, absolutely. There's a competition called ImageNet, considered the Olympics of computer vision.
Okay.
Algorithms compete to see which can classify images most accurately.
Right.
And VGGNet didn't just participate.
Mm-hmm.
It dominated.
So a gold medal performance?
Mm-hmm.
I'm guessing that kind of win put them on the map, right?
More than that, VGGNet became the gold standard, a benchmark for future models. But what's really interesting is how it achieved that success.
Yeah.
Instead of creating a completely new architecture, they focused on depth, proving that a deeper network, meticulously designed, could lead to a giant leap in performance.
That's a really interesting insight. Sometimes progress isn't about reinventing the wheel. It's about refining and deepening what already works. But I'm curious, did Simonyan's work ever move beyond recognizing objects in still images? What about videos?
You're right to ask that. Simonyan didn't stop at images.
Yeah.
He wanted to tackle the complexity of video analysis,
Right.
understanding actions and movement over time.
That's a whole other level.
Videos are constantly changing, way more dynamic than a single picture.
Right.
How did he even approach that?
He developed something called a two-stream convolutional network.
Okay.
One stream analyzes the still frames, like VGGNet, while the other focuses on optical flow, conceptually how things are moving within the video.
Okay, two streams working together to make sense of the video.
Right.
Can you give me a real-world example of how that optical flow analysis would come into play?
Think about self-driving cars.
Okay.
They need to understand not just the objects around them,
Yeah.
but also how those objects are moving.
Right.
Optical flow analysis helps them predict, say whether a pedestrian is about to cross the street.
Right.
Or if a car is slowing down.
That's incredible.
Yeah.
So Simonyan's work isn't just theoretical, it's having a real-world impact on things like transportation and safety. But his research goes even deeper than that.
Right.
It touches upon some pretty big questions about how we build AI we can actually trust.
Exactly. And that brings us to the heart of some of the ethical considerations surrounding AI.
Hold on. You can't just leave me hanging there. What are these considerations? What are the challenges in building trustworthy AI?
We'll dive into that right after this.
Oh, come on.
Stay with us.
All right. So we left off talking about the challenges of building trustworthy AI. It sounds like there's more to it than just making sure the code works right.
You hit the nail on the head. As AI becomes more sophisticated, we need to make sure it's not just powerful, but also reliable and understandable.
And that's where things get tricky, right? Especially with these complex deep learning models. How can we trust something if we don't fully understand how it works?
Exactly. It's like trying to trust a chef's recipe when you can only see the ingredients going in and the final dish coming out.
Right.
You have no idea what happened in between, what steps they took or choices they made along the way.
So how do we get a peek inside the kitchen, so to speak? How do we make these models less of a mystery?
One of the big challenges in AI right now is something called the black box problem. It refers to the fact that even the people who design these complex AI models sometimes struggle to fully understand how they reach their conclusions.
That's a little unsettling. Can you give me a real-world example of where that lack of transparency could cause problems?
Think about AI being used in medical diagnosis.
Okay.
A model might be really good at spotting patterns in medical images. But if we don't understand why it's flagging something as potentially cancerous, doctors are less likely to trust its recommendations.
That makes perfect sense. You need to know the reasoning behind the diagnosis, not just the diagnosis itself. So are researchers trying to open up that black box to make these models more transparent?
Absolutely. There are a few different approaches being explored. One is to develop techniques that let us visualize what's happening inside the model.
Okay.
To see which parts of the input are influencing its decision. It's like giving the AI the ability to show its work so we can follow its logic.
So it's not necessarily about simplifying the AI itself, but more about giving it a way to communicate its reasoning in a way that humans can understand.
Precisely. It's about building a bridge between the complexity of the model and the need for human interpretability.
That seems crucial, especially as AI starts to play a bigger role in areas like healthcare, finance, and even legal decisions. But where does Simonyan's work fit into all of this? Is he tackling the black box problem directly?
While Simonyan's main focus has been on developing highly efficient AI architectures, his work has indirect implications for trustworthiness.
I'm not quite following. How does efficiency relate to trustworthiness?
Think about it this way. If AI models require massive amounts of computing power and data, only large corporations and institutions with vast resources will be able to develop and utilize them.
Okay, so the more resource-intensive AI is, the more it becomes concentrated in the hands of a few. But how does Simonyan's work challenge that?
Simonyan's drive for efficiency is in a way a drive for democratization. By making models less computationally demanding, he's paving the way for smaller organizations, researchers, and even individuals to work with and understand these powerful tools.
So greater access leads to greater transparency. That's an interesting perspective. It's like making sure the recipe isn't locked away in some high security vault, but available to anyone who wants to learn from it.
Exactly. And that wider access can lead to more diverse perspectives, more scrutiny, and ultimately more trust in how AI is developed and used.
So we've talked about his groundbreaking work at Oxford and the broader implications for trustworthy AI. What's next for Simonyan? Is he still pushing the boundaries of what's possible?
Well, word on the street is that he's continuing to focus on efficiency, pushing the limits of what AI can achieve with fewer resources.
And why is that such a big focus right now? Is it more than just wanting to make things faster?
It's about making AI accessible everywhere, on every device.
Yeah.
Think about your phone, your car, your smart home devices. There's a growing push to have AI running directly on these devices rather than relying on the cloud.
Oh, right. So instead of constantly sending data back and forth to some massive data center, the AI could just work locally, making things faster, more responsive, and maybe even more secure. But can our phones really handle that kind of processing power?
That's the challenge. And that's why Simonyan's focus on efficiency is so important. He's working on creating AI that's incredibly powerful, but also incredibly lean, efficient enough to run on everyday devices.
It's almost like he's trying to fit a supercomputer into our pockets. And what kind of impact could that have on the future? What are the big areas where this kind of efficient AI could really take off?
Well, two areas that immediately come to mind are sustainability and robotics.
Now, those are two topics I'm really interested in. But how does Simonyan's work connect to something as broad as sustainability?
Let's dive into that right after we take a quick...
Wait a minute.
To hear from our sponsors.
Oh, come on.
Don't go anywhere.
All right, so before we got sidetracked, we were starting to unpack how Simonyan's work could have a huge impact on sustainability.
Right.
It seems like a bit of a leap to go from efficient AI to saving the planet, so help me connect the dots.
Well, as AI models become more complex and powerful, they also require more energy to run.
Yeah.
Training a single large language model, for example, can consume as much electricity as an average American household uses in several years.
Wow, I had no idea it was that energy intensive.
Yeah.
So are we talking about a potential environmental costs to all this AI progress?
It's definitely a growing concern.
Yeah.
And that's where Simonyan's focus on efficiency comes into play. If we can make AI models less computationally demanding year apart, they'll require less energy to train and run.
Right.
This could significantly reduce their carbon footprint.
So it's not just about making AI faster and smaller, it's about making it greener. And I imagine this ties into the whole idea of using AI for sustainability, right?
Exactly. There's a whole field emerging around using AI to tackle environmental challenges.
Okay.
Think about optimizing energy grids, designing more eco-friendly materials, or even tracking deforestation patterns in real time.
That's amazing. So AI can actually be a tool for environmental protection. It's not just some energy-guzzling monster.
It definitely has the potential to be a force for good in that realm.
Huh.
And Simonyan's work on creating incredibly efficient AI architectures could be a key enabler for these applications.
All right, that's sustainability. But you also mentioned robotics as another area where Simonyan's work could be game-changing.
Right.
What's the connection there?
Well, robots rely heavily on computer vision to understand and navigate their surroundings.
Okay.
They need to be able to see objects, recognize people, and make decisions based on visual input.
So Simonyan's work on image and video analysis is essentially giving robots a more powerful set of eyes.
That's a great way to put it.
Yeah.
And his research on video analysis and understanding motion is particularly relevant for robotics. After all, robots operate in dynamic environments where things are constantly moving and changing.
So could we see robots becoming more adept at navigating complex environments, interacting with objects, and maybe even working more seamlessly alongside humans?
Absolutely. Simonyan's work could lead to robots that are more perceptive, more adaptable, and ultimately more capable in a wide range of applications.
This is also fascinating. It seems like Simonyan's work has had and will continue to have such a profound impact on so many aspects of technology and our lives.
There's no doubt about it. He's a true pioneer who has helped shape the landscape of modern AI. And as AI continues to evolve at this incredible pace, it's important to remember the ethical considerations we touched upon earlier.
Right, because it's not enough to just make AI more powerful. We need to make sure it's used responsibly and for the benefit of humanity. It's a responsibility we all share.
Well said. And hopefully this deep dive into the work of Karen Simonyan has given you a glimpse into where AI has come from and where it might be headed.
It certainly has for me. From those early days at Oxford to the forefront of AI research, it's been an incredible journey to follow, and I have a feeling this is just the beginning.
I think you're right. The possibilities of AI are vast and still unfolding. It will be fascinating to see how Simonyan and other brilliant minds continue to push the boundaries and shape the future.
Thanks for joining us on this deep dive, everyone. Until next time, keep exploring, keep questioning, and keep learning.